Last week, we got a little introduction to binomial expansion, but we kept it pretty limited. We stopped basically at row 5 of Pascal's triangle. But what happens if you have something to the 20th power or the 15th power? How can you deal with that? So that's what we're going to be doing here, is we're not limiting ourselves to the 5th row of Pascal's triangle. We can do it for any row of Pascal's triangle with any exponent. When you are looking at an IB test, you're not going to be asked to find the entire final polynomial. That's kind of a waste of time. Instead, they're going to ask you maybe for just one specific term. So that's what we're going to be doing in this lesson. So first example, we're going to use binomial expansion to simplify the following. And then, this is a very important term, we're going to highlight the constant term, and I'll discuss that towards the end. But you'll notice that this one looks a little bit more confusing just because we've got variables on the top and the bottom. So we'll show you how to deal with that. So since it is a 3, we are going to use row 3 of Pascal's triangle. 1, 3, 3, and 1. And then we're going to take that first term, which is x squared, and we're going to raise it to the highest power possible, which is a 3. And we have the next term, which is 2 over x, and we raise that to the lowest power possible, 0. And I bet you know how to fill out the rest of this, but in case you don't, you can go ahead and follow along. And one more term. So this is how we set it up. Now let's go ahead and simplify. For that first term, anything to the power of 0 is 1. 1 times 1 is 1. And if you have x squared raised to the 3rd power, that becomes x to the 6th power. Then for the next one, we have 3. We're going to multiply it by x squared squared. That becomes x to the 4th. And that gets multiplied by 2 over x. And to simplify this one, we can just take the 3 times 2, and that's going to equal 6. And now you might be wondering how to deal with this. X to the 4th with an x on the bottom. Well, x to the 4th, what that means is 1, 2, 3, 4. And x on the bottom, 1x on the bottom. One of them is going to cancel out. So you're left with a grand total of x to the 3rd power. So if there's 4 on top, 1 on the bottom, 1 will cancel out, and you're left with 3 of them on the top. We'll go ahead to the next term. We start with the 3. X squared to the 1st power is simply x squared. And if we take 2 over x and square it, it becomes 4 over x squared. And now we simplify this. 3 times 4, that's a 12. And you'll notice an x squared on top and an x squared on the bottom. Let's show you what happens here. They just cancel out. There's no more x's. So it's x to the 0 power, which is just 1. So 12 times 1 is 12. And the last one, anything to the power of 0 is 1, times 1 is 1. And this just becomes 2 to the 3rd, which is 8 over x cubed. So here are your final terms, right here, 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 and here. So if we write it as a polynomial, we have x to the 6th plus 6x cubed plus 12 plus 8 over x cubed. Another way of thinking of 8 over x cubed, you may see it written as this way, 8x to the negative 3. These two mean the exact same thing. But typically I like to write things with positive exponents. So at the very, very, very end, it says highlight the constant term. This is our constant term. A constant term is going to be the one that has no more variables. And a lot of times in these IB exams, they ask for that constant term. It's the one where the variables disappear. So go ahead and try the next one on your own. Find that constant term, and when you are done, then we will move on and do a couple more examples. So go ahead and pause the video and then come on back. Okay, for the rest of these examples, what I'm going to be doing is I'm going to ask you to find a specific term. And sometimes it's going to be like a puzzle, where sometimes it's an easy puzzle, Sometimes it might be a little more difficult of a puzzle. But I'm only going to ask you for one term. I'm not going to ask you to do the whole thing. That would be very, very cruel of me. And I'm not cruel. So the first example says to find the x cubed term in this expansion, 4x minus 1 to the 9th power. So the first thing I'm going to do is, I have Pascal's number, and I know it's going to be a 9 on the top. And I'm going to leave this bottom blank, and I'll deal with that in a second. And I know I'm going to have my first term, which is 4x, and it's going to be raised to some exponent up here, but I'm not going to fill that in yet. And I have my next term, negative 1. And again, that will be raised to some exponent. I don't know. I'll fill it in a bit. So the key here is it says we want to find the x cubed term. Well, the only way to get x cubed is if I put a 3 up here. Now, if this is a 3, then the other one over here should make it add up to 9. So that's going to be a 6. And here's the important part. Whatever you have up here should match with what you have down here. So if that's a 6, well, then that's also going to be a 6. And then we can just simplify and evaluate. So if you do 9 choose 6, you can just do that on a calculator. That's going to be 84. Remember, that's the NCR button on Desmos. So if you find NCR, do 9, 6, it should give you 84. If we have 4x to the 3rd power, that's 4 times 4 times 4, which is 64, x to the 3rd. And negative 1 to the 6th, if you've got an even exponent, it's going to be positive, so that's negative 1 times negative 1 over and over and over. That's just a positive 1. And then finally, you can just multiply all of those together. So if you take 84 times 64 times 1, it gives you 5,376, and then it is x to the 3rd power. And that would be the x to the 3rd term in that expansion. So I'm not asking you to do all of them, we're just finding one of them. So go ahead and try the next one on your own. Pause the video here, give it a shot, and then see how you do. And then come on back for yet another example. Okay, so now the puzzles are going to get a little bit more difficult. The last one was pretty straightforward. This one requires you to think a little bit more. So next one says find the constant term in this expansion. So we have our Pascal's number, which is going to start with an 8. We don't know that bottom one, that's fine. We will have our first term, which is 4x. And we have our next term, which is 3 over x. And we have to find the constant term. Now, if you remember from earlier, the constant term is the one where all the variables disappear. They go away. So in this case, we have to come up with a set of numbers here where the variables on the top and the variables on the bottom will disappear. And in this one, it's not so bad. I think maybe you realize this will be a 4 here and a 4 here, because you're going to have x to the 4th on the top and x to the 4th on the bottom, and then they just end up canceling out. So since this one's a 4, we're going to put a 4 down here as well. And let's go ahead and see what happens when we simplify. If we do 8 choose 4, that's going to be a 70. And if we do 4x raised to the 4th power, it's 4 times 4 times 4 times 4, that's going to be 256 x to the 4th. And for this last one, we have 3 to the 4th gives you 81. And then on the bottom, it will be x to the 4th. So you'll notice here, what happens is this x to the 4th and this x to the 4th end up canceling out, leaving you no more variables. And that's why you're left with the constant term. So all you have to do, multiply straight across. 70 times 256 times 81 is 1,451,520. I told you in the last video, we're going to get some big numbers here. So go ahead and try the next one on your own. There's something a little bit different about this. It's a little bit more difficult of a puzzle, but go ahead, try figuring it out, see how you do. Pause the video, come on back, and I'll even give you a little hint when you come on back. Okay, if you did it correctly, this is what your setup should have looked like. You might have tried putting a 3 and a 3 there, and hopefully you realize that doesn't work. But by putting 2 and a 4, that first part will have an x to the 4th component, and that next part would have an over x to the 4th component, and then they end up canceling each other out. So hopefully the numbers aren't an issue for you, but dealing with those exponents sometimes can be a hassle. Let's go ahead to the next one. This one says find the 6th term in this expansion, 2x plus 5y to the 15th power. Now, you'll remember if you have to the 15th power, there's actually 16 terms. I'll draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's going to be 16 terms here. And for Pascal's triangle, to find that first one, it would be 15, choose 0. The next one would be 15, choose 1, and so on and so on. If I'm trying to find the 6th term, that's 1, 2, 3, 4, 5, 6. That's this one right here that I'm trying to find. So this is 15, choose 0, 15, choose 1, 15, choose 2, 15, choose 3, 15, choose 4. This would be 15, choose 5. So that's going to be your Pascal number. To find the 6th term, we have to do 15, choose 5. And then the rest of it's pretty straightforward. We take our first term, which is 2x. We have our second term, which is 5y. And remember, this number will match with that exponent here. So we're going to put a 5 up here, and that becomes a 10. And we can just simplify the rest of the way. So if we have 15 choose 5, that is 3003. If we have 2x to the 10th power, that's going to be 1024 x to the 10th. And if we have 5y to the 5th power, that's going to be 3125 y to the 5th. And then we just multiply all these together. So take this and this and this, multiply all the way across, and you get a really, really, really big number. 9,609,600,000. Don't forget your variables. It's x to the 10th, y to the 5th. Really, really, really big numbers. Go ahead and try that next one on your own, and then come on back for the last example. All right, last one, pretty similar to the one we just did. Find the 10th term in this expansion. So I'm going to start out with the 17. And again, if I want the 10th term, it's going to be 17, choose 9. And then we're going to take that first term, which is x squared. And our second term is negative 2 over x. This 9 is going to match up here with a 9. And these two exponents have to add to 17. So this will be an 8. And then it's just a matter of simplifying. So 17 choose 9 is 24,310. If we have x squared to the 8th power, that becomes x to the 16th power. And if we have negative 2 to the 9th, that becomes a negative 512. And on the bottom, it will be over x to the 9th power. And some exponents will end up canceling out. So x to the 16th on top, x to the 9th on the bottom. 9 of them cancel out. So you will be left with 7 of them. So if we multiply straight across, we're going to get, once again, a really big number. 12,446,720. And the final exponent is x to the 7th. So you've got one more to do here, and then you can move on to the next part of the assignment where we will be solving for a specific term. So we'll solve for one of those terms within the binomial. Fun stuff. So look forward to that, and then you will have a quick homework assignment at the end.